looking at magnetic force on moving charged particles. So, foundational fact number 2. If a charged particle is moving perpendicular through an already existing magnetic field, then it'll experience a magnetic force that's perpendicular to both the velocity and the magnetic field. So the equation that describes the strength of that force is given by this. So magnetic force is F sub B is equal to magnetic field multiplied by the charge of that particle multiplied by the velocity that's perpendicular to the magnetic field. So we have a component of the velocity that's perpendicular to the magnetic field. That's what that V perpendicular is. So this is a component of velocity that is perpendicular to the magnetic field. Okay. So what would cause this magnetic force to increase? Well, if you increase the magnetic field, if you increase the charge of the object, and if you make it go faster, specifically, or make it more perpendicular to the magnetic field. So, give it to me. All right, so the SI unit for magnetic field is a Tesla. We've heard of those, but not for magnets. Tesla is the unit for magnetic field. So B this is the variable for magnetic field, and T is the unit. Okay. Sometimes you hear Gauss. Gauss is another unit. It's 1/10,000th of a Tesla. Tesla is pretty big. So we use Gausses sometimes in lab, but for this class we'll just stick with Tesla. So we have a second right-hand rule. This is for when a charged particle is moving through an already existing magnetic field. So the already existing magnetic field are your fingers, so still B. Your thumb is the direction of the velocity of the moving charged particle, and the force is whichever way your palm is pushing. So that's the direction of the magnetic force. Notice they're at right angles to each other. So you got like the X, Y, and the Z axis coming out of the page, and that can always move around. The exception for that is if you have a negatively charged object, then you're pushing with the back of the hand. And that's what this exception thing is here. So if you have moving charged particles going through our existing magnetic field, what happens if you have a current through a wire that's going through a magnetic field? Probably experiences a force. And how strong that force is determined by the strength of the magnetic field, the length of a wire that that's in the magnetic field, and how much of that current is running perpendicular to the magnetic field. So what would cause this force to increase? Well, stronger field, more wire, and increase the current that's going perpendicular. So you could either increase the magnitude of the current or orient it so it's going perpendicular to the magnetic field. That's what we got.